Hi, I'm Dave Schatz with DHS Equipment. We can be found online at dhsequipment.com or dhsequipmentparts.com. Today I'm going to go over a few things in regards to rebuilding your exciter assembly on your Wacker reversible plate compactor. We are not going to do a complete rebuild. We're just going to go over some timing and different sealants and a couple of things to look for, some items that get worn that you may not be aware of. This way you're not rebuilding it in a year from now. If you do a proper rebuild with the proper materials in the proper way, proper bearings and sealants, you should get a lot of years on these exciter assemblies. So I'm going to go highlight a few of these things for you and we'll go from there. Okay, so today the exciter assembly that we're working with is the Wacker BPU2540A. The thing about this exciter versus some other exciters, timing is slightly different, and this is also a little bit different than the older model, smaller reversibles. We're going to start with removing the pulley. The nice thing about some of the exciter parts that Wacker makes, they've got some things added into it to make it easily removed. This particular one, this is the 2540 and the 3050. Inside the pulley, you'll notice it has a hole. That hole lines up with a hole in the housing. You could take a drift pin or you could take anything until you locate that hole and it locks the pulley. Now you can get your wrench on this bolt and the pulley's not going to move, the weights aren't going to move, the shaft isn't going to start rotating on you. So you've got some little things like that on the 2540 and the 3050. The older version small reversibles, the 2440 and the 2950, there was a bolt similar to this in the center, but it was only a vent. The bolt did not have to be removed in order to remove the pulley. The pulley on the old shaft was on a straight shaft and used a tolerance ring, and the pulley just pulled right off. This particular pulley, you do need to remove the bolt. This pulley sits on a tapered shaft. So what we normally do is we loosen that bolt a little bit, not completely, because what you're normally going to do now, ours is already loose. Normally, with the bolt pulled out about 1/4 inch or so, because this is a short tapered shaft, it doesn't take very much to pop the pulley off of the shaft. So you put your 2-jaw puller on there and just pop it, and once it pops the taper, then you can just pull the pulley off. We'll go ahead and finish taking that off, and then we'll slide it around and move on to the cylinder. Okay, this was already loose, so we'll set that to the side. We'll slide this around. We'll get to the next thing that we're going to remove. This is the hydraulic cylinder. This hydraulic cylinder is similar on all of their reversibles. And what Wacker does is they supply a little hole, a little threaded hole on 2 spots of the cylinder to use as pusher bolts. So once you remove the bolts that hold the flange on there, you're going to take one of the long bolts and thread them in, and that's going to be used as a pusher bolt, and that's going to slide this cylinder off. Do not use a hammer on this. I know with the sealant on there, sometimes it's a little tough and people tend to hit it with a hammer, but you've got your hydraulic piston inside. If your hydraulic piston is bent because you're hitting this with a hammer, you're going to have to replace that, and depending on what model, it's a couple of $100. So whenever you see a threaded hole with a little short screw, that's used as a pusher bolt. Okay, so now that we've removed all of the longer bolts, we've removed the bottom short bolt, we'll go ahead and remove this little short bolt on top also, and we're going to replace it with this longer bolt. This longer bolt will go right in. Nice and slow, and once it starts to move, there's one at the bottom also. You want to do it evenly to not bend anything. So that's got the flange removed from the exciter, and we'll just pull that out. Okay, so now this is ready to slide off. In regards to this hydraulic cylinder, one of the things we want to look for is get a good inspection light, get inside. You could even run your finger all around here, make sure there's no gouges or scrapes or anything like that that would allow the hydraulic fluid to bypass. and not accurately have this reversible plate go forward and reverse. So we'll take a little inspection in here, and then we will take the next step. Now, on the 2540 and the 3050, you may notice it has a set of wheels on the back. When you've got a set of wheels, it's pretty easy to identify the back from the front of the machine. On a lot of the other reversibles, they don't have the wheels, and sometimes, just for reference, when you go to put everything together, you don't want to put things together backwards, especially if you're not going to remachine anything. Okay, so what I like to do is take the hydraulic side and just put an H on the exciter in one or two places, so I know which side is the exciter side of the hydraulic side when we reassemble. And then for reference, again, not so much with this one because we know where the back is, I would just take the same marker and put an H on the back. This way, when everything's together, I don't have to now go figure out where's the belt side, where's the hydraulic side, is this the front, is this the back. So it's just two little marks for easy orientation. Okay, so the next thing we'll do is we'll go ahead and pull this cover off, and then we'll pull the exciter off. Okay, now that we have the exciter housing off of the machine, there's a couple of things we want to look for. The very first thing we want to do, the oil has already been cleaned up. The first thing we want to take a really good look at, we'll insert a couple of pictures so you can see it better, is the machine marks all around the mating surfaces. This base plate is perfect. This machine is only about a year old. We're only taking it apart for the purpose of this video. So on a new machine, you're going to see these beautiful machine marks on the base plate, and also you're going to see the same marks on the exciter housing. So for the purpose of the video, we're going to go through the next couple of steps anyway, but that is a very important step, because if you're missing some machine marks and you've got some low spots or worn spots, you're going to be losing oil, and if you're losing oil, you're not going to lubricate the bearings, and this is a very expensive repair to do. So the next thing we're going to look at, now that we know our machine marks are good on this one and on this one, we're going to do, it's called a high spot test. And if this was not a new machine and you didn't see all these machine marks, what we want to do is we want to determine, does this base plate and does this exciter housing need to go get machined to have a better surface? So that's what this next test is. This next test is some high spot blue. And all you're going to do is, blue gets everywhere, so a glove is definitely recommended. This is something that machine shops and metal shops use. We're just going to put the blue all around on one side. Then we're going to put the housing back on top. And we're going to torque it down to the normal torque specs of this machine. And then we're going to remove it. And we're going to make sure we can see the blue transfer on the other side. Okay, and then this will determine if we have any low spots or if this machine base plate or housing needs any machine work. Okay, so that's done. Now here's an important step. If you go to flip this housing over, whether you've got it full of eccentric weights or in the gears and everything or not, it's still a little bit heavy. And what happens is if you flip it over, it tends to slide around, especially now that you got this blue gunk everywhere. So to prevent it from sliding around and getting a false read on the housing, we've got a couple of studs that we're going to use for alignment purposes. This way, once we align these two bolts, it'll slide right down and we don't have to worry about having anything slide out of the way and give us a false reading. We're also going to use these later when we put our sealant on and put the housing on, because the same thing, if you put the housing on and it slides, you just removed half your sealant. Okay, so now we're going to go ahead and put the housing on, and then we'll bolt it down, we'll torque it, and then take it off and we'll check our high spots. Okay, we torqued it down, we removed it, and this is what we see. Now this is perfect. There's no missing areas, other than where my sweat is dripping. There's no missing areas. So we've got a very good mating surface right here. Okay, so one of the things we want to also look at is the fact that this has a perfectly good surface and it doesn't need to be remachined. This is all the more reason that we marked our spot on the exciter housing and on the base plate itself over here. Because if we're not going to remachine this, we definitely want to put this housing on in the same orientation that it came off with. Because for the last year, it's kind of worn in. This base plate and housing have worn together, and we don't want to reverse that. So that little reference mark for the H for the hydraulic and the H for the hydraulic over here, we want to maintain that. Now, if by chance we had some low spots and this had to go to a machine shop to get resurfaced or milled, then this would not be as critical as far as the mating of the housing and the base plate go. But the fact that our surfaces are the way they are, this is going to be more important. So our surfaces look real good. This is extremely helpful. So the next thing we're going to look at is if this was not a perfect mate, if we had some wear marks causing us to go to the machine shop, this is where the wear marks normally are. Right around here, right around here. Okay, it's possible to have them over here or in the corner because a bolt broke or something along those lines. A bolt got loose and this thing is just sitting there vibrating to death and starting to wear down a corner. But that's not nearly as common as having wear marks by the shafts. And what causes this is over compaction or compacting on a hard surface. So you're done compacting, you don't want to go bring your loader over to pick the thing up, so most people will walk this across the street or they'll walk this over a sidewalk or something like that. And when you hit hard surfaces or when you over compact, that energy doesn't go into the soil, it stays in the machine. And these weights are carrying, these shafts are carrying the weights, so you tend to get a lot more wear in these areas. Okay, so if your machine marks are gone and you have some low spots, you'll probably notice almost like the metal looks pushed away a little bit or it seems very dull. So you'll have some real nice machine marks and then it'll get dark and dull. That's for sure a sign of over compaction or compacting on a hard surface. So this would definitely have to go to a machine shop, and then when you get it back from the machine shop, do this same test again, because this is where you'll determine if you wasted all that time and money doing bearings for no reason. Because if you have an oil leak, you're going to be doing bearings again very shortly. Okay, so that's about all I've got to say about the surfaces, and let's move on to the next thing. Okay, so we went ahead and pulled out the shaft with the sleeve gear and the hydraulic piston, and really we didn't need to pull this out to show you the timing, but there's a couple of important things to look at before we do anything. So the first thing we're going to do is we'll address the timing here. We'll address it later when we go to assemble it, but we're going to address the timing here. The 2440, 2950, the 3050, and the 2540, the smaller reversibles, they're timed differently than the bigger reversibles as far as how to set the timing up in the sleeve gear. So the way to check timing on these, and Wacker will make reference to the piston in or out. Right now this shows the piston is pulled out. So with the piston pulled out, the bolt hole that holds the weight on is in the same location or the same orientation as, you may not be able to see it, as the little timing mark right in here. There's a little timing mark right on this gear. So the timing gear mark is on top, the bolt hole is on top, and the piston is pulled out. This is how you set your timing for the sleeve gear on the 2440, 2950, 2540, and the 3050. Your bigger reversibles, the 3345, 4045, 5055, 6055, all the bigger reversibles is exactly opposite. On those, with the piston pulled out, this bolt hole would be opposite when it's pulled out. So you'd have the piston pulled out, you would have the bolt hole on top, and if you flipped it over, you would have the timing mark on the opposite side. So the bigger ones get timed opposite of this. When in doubt, give us a shout. We're happy to go over it with you. So that's just a little bit about the timing now. When we assemble this, we'll go over it again, and then we'll show you the timing from this gear to the other shaft gear. Okay? So the main reason I pulled this out is I wanted to show you something that really nobody ever looks at, or nobody really knows to look at. On the older machines, it didn't have all these bushings. It just had a regular bearing in the back, maybe a little bit easier. There's a lot of extra parts and pieces to the newer ones than the older ones. But on the older ones, they have what's called the tripping pin. This is the tripping pin. This is the pin that rides in the helical gear of this sleeve gear. Now on the older ones and the bigger ones, this pin is pressed in. And what happens is, every time this pin is pushed forward and backwards because of the hydraulic pressure of the control head, it rotates this gear back and forth, back and forth. So after a while, this pin will have flat spots on this end and this end, or this side and this side, and flat spots on this side and this side. So if you're in here doing bearings, it is a best practice to replace this pin because the pin is starting to get worn. Now, with the newer machines, the fact that they don't get pressed in, they just slide in, I'm not 100% sure if this pin rotates at all. That's why there's no flat spots, but definitely something to check out. If your pin has any kind of flat spots, that could give you a problem where it's getting stuck inside the gear and that gear is not rotating correctly on the helical spin. So flat spots on the pin, very big to look at. Now on the gear itself, this is the gear that this pin rides in. If you can see inside, there's a helical cut. So when this piston pin goes back and forth, it's rotating this gear back and forth because of the helical gear, the helical cut rather. So one of the things that we have to look at in here is where the pin rides, right around this edge, sometimes there's a buildup of crud. You know, you don't change your oil very often, or if there's metal particles or flakes or any junk that just accumulates in your exciter from time, age, burnt oil, whatever, it accumulates inside this helical cut. And that will also give you a problem with the gear rotating correctly. So when this is all broken down, you want to take your sleeve gear, get yourself a little 90-degree pick, get in there and really clean out that helical cut on both sides, and then get the other side of the gear, and you really want to get in there really well. Get this thing, sit in your parts washer, let it loosen up some crud, but you really want to get in there and get as much as you can out of this helical cut. Okay? So we went over the cleaning of that, we went over the flat spots on the pin, and that's about it. We're going to go ahead and reassemble this shaft now to the sleeve gear. We're going to put it back in the exciter, and we'll wait for the last step. We'll show you the last step where we time it again, and then we'll go ahead and time the piston to the sleeve gear. We'll time the sleeve gear to the other gear, and then we'll just put our weights on, and then we'll kind of take the next step. Okay. So we went ahead and put the shaft back into the exciter assembly, pressed the final bearing in, and now it's pretty much in place. And we're going to check our timing again before we go any further. So as I mentioned before, with the piston in the pulled out position, our bolt hole is to the top, our timing mark is to the top. So this sleeve gear is timed correctly for the smaller machines. Again, the bigger machines are opposite, But for the 2440, 2550, I mean 2540, 3050, 2950, these get timed piston out, bolt hole up, timing mark up. This gear and sleeve are timed. The next thing we're going to do, because this is not in place yet until the weights go in, so we could still make adjustments. We could still have the gear slide in and out. So what we're going to do now is rotate around that timing mark until we find the other timing mark, which is right here. I don't know if you can see it very well. Okay, so as they mesh, they'll line up, and we now know this timing mark is marked with this one. This is timed, our exciter is timed perfectly right now. Okay, so the next things we're going to do is we're going to put our weights on, and we're going to put our caps on. Now, here's the thing about the weights, and more specifically the washers. These washers, it's kind of hard to tell. This is a cupped washer, kind of flat on one side, but you could rock them a little bit on the other. These washers should be replaced. After a while, they start to lose their tension, and they're no longer a lock washer, it's just a regular washer. So what you want to do is replace these washers. Okay, so I've got some new washers here, and we're going to go ahead and use these on our weights. The other thing is, when you use a lock washer, a cupped lock washer, the cup, the high end of the cup goes up. Okay, so that's the part where the bolt hole, where the bolt head is going to be. I don't know if you can see that. So it's cupped like this, and then the bolt goes on, so when it gets tightened, the cup kind of gets squashed down. Okay, if you do it the other way around, where it's the cup side up, you're defeating the purpose, and these weights are going to come loose, and then you're going to have a problem. So cup side down, new washers, and then we'll torque these in and put the weights in and torque them down. The other thing we're going to mention is when you're dealing with the bolts that hold the weights on, make sure the bolts and make sure the threads are clean and dry, and you want to use a red thread locker. Don't forget the thread locker. You don't want one of these weights coming off while this thing is going. So red thread locker on the big bolts, and all these little bolts all around, a blue thread lock is okay. Okay, so we're going to put these bolts on, these weights on, and once the weights are on, we're going to go ahead and put the rest of our caps together, and then we're going to put this exciter onto the base plate. And one last thing. Loctite 518. Doesn't have to be a 518, but it could be. It has to be an equivalent. This is an anaerobic sealant. That means it cures in the absence of air. So that means on a metal flange, as soon as we put the two metal flanges together, the housing and the base plate, once the two metal pieces are together and there's no more air getting into it, that's when it's going to cure. You have to use an anaerobic sealant for these surfaces. The same sealant is going to work on the back of these flanges, the other end of the flange, and then when we put this other cylinder on, you're going to use it on the back of all the flanges. Don't use an RTV, don't use regular gasket maker. They don't last and they don't hold up at all. Some of the RTVs are very resilient, these are very rubbery. They don't cure, they stay spongy. And that could cause the exciter to start moving back and forth a little bit. So you've got to use a good quality anaerobic sealant. This also will fill gaps up to 1/4 millimeter, just in case you do have some little imperfection, whether you got it machined or didn't get it machined. This is really the best product to use. Been using it for about 25 years now. And that's it. I'm going to go ahead and seal this up and get it mounted to the base plate, and we'll see you shortly. Okay, so the last couple of images that you just saw in the video were us using those threaded rods for alignment purposes, and it really is a big benefit. Those exciters are kind of heavy, especially when they've got the weights on it and whatnot. So if you use those threaded rods as a guide, there's no way you could miss. So it's very, very great tip right there. For the exciter assembly, we used a 10W40. The majority of the exciters on the reversibles use a 10W40 regular motor oil. We went ahead and finished everything up. We tested the machine. Everything works great. When you put the upper and lower assembly together, most of the compactors, most of the reversibles are going to call for an MRO 520 hydraulic oil. That's really not easily found. That's something that they use over in Germany where most of these are manufactured. But it is equivalent to a regular 10W30 motor oil. So these control heads, standard 10W30 motor oil, that's it. This particular machine is self-bleeding, so there's no little screw on the cylinder that you have to deal with. Just fill it up to just above the top of the gear. When you open up this port, you'll see the top of the gear. The oil level is to the top of the gear. Just work it a few times, operate it. When you're done operating it, go ahead and pull the plug, check it again, and that's it. Thanks for watching, and see you next time.